Hello, my name is Jack Elston. I'm here with Black Swift Technologies. We're a custom unmanned aircraft solutions provider, and I'm here to talk to you today about a project that we've been working on with a partner, Orbital Microsystems, to provide soil moisture mapping from unmanned aircraft systems. So soil moisture is important for a number of different reasons, but in particular, we're going to need it to start developing solutions around. According to the World Resources Institute, water stress is going to increase significantly in just a couple of years from now. And this is mainly due to growing use of the agricultural land and then also higher temperatures. Unfortunately, to combat this, we don't have a lot of information to start developing systems, as currently we get our information from satellites, which have very low resolution information, and then also from manned aircraft, but those are kind of expensive and difficult to get on a regular revisit time. Soil moisture is important for your agricultural applications, and the fact that it helps you make informed decisions about irrigating crops. We were working with a number of different institutions and universities and showing that increased knowledge about the amount of soil moisture contained within the ground can increase the yields and profits, as well as providing very different ways for us to mitigate droughts and the effects of them. Furthermore, it'll also allow for the uses of fertilizer to be optimized in such a way that you're not risking things like runoff into the local streams and water systems, which can result in very large fines. So we've put together a L-band radiometer-based instrument. It's been developed underneath NASA SBR in conjunction with the Center for Environmental Technology at the University of Colorado. And it's capable of measuring soil moisture content up to about 5 centimeters below the ground, depending on soil type. We've put this in a custom designed vehicle that's specifically tuned to the instrument. It allows us to get very accurate measurements. The vehicle itself is able to fly about 600 acres per flight, depending on the resolution that you desire. And we're able to correlate some of the preliminary results that we've had from this very accurately with in situ probes. This vehicle, we've flown 12 successful missions so far at 4 different sites. This aircraft we call the S2 UAS. Again, it was designed around the particular payload of providing soil moisture information, but since it has a swappable payload, it's fairly capable in the fact that we can carry a number of different sensors. And in fact, the soil moisture solution requires the use of several different cameras, so as intermediary products to the soil moisture product, you're able to get both thermal data from the ground below and then also multispectral information. So just to get into some of the field testing results that we've had, we were lucky enough to be able to fly over an area that had a number of different crops. This was useful in the fact that a part of our algorithm is actually to take measurements of the biomass that's underneath the aircraft and be able to subtract out the water content that's contained within that, so we're only providing the water content within the soil. And so you can see here on this map, there's several different irrigated portions. They're able to finally irrigate these in different ways, and they contain a number of different crops. Furthermore, we were able to get the soil type information and use that as part of the algorithm, and took the instruments with the aircraft, overflew it in the flight pattern that you could see here, and we're able to generate these soil moisture maps using one of our proprietary algorithms. And you can see here, this is a soil moisture map from 2 different days that we flew over, one on June 20th and another one 3 days later. And we've identified those irrigated circles again, along with the crop types in these images. And we've pointed out a few significant things that have happened here. This was, there were no natural rain during this time, so everything was done through, all the watering was done through irrigation. And you can see from on the bottom left-hand corner there, the soybeans that are located there, you can see how they got slightly wetter during this time, and that's because they were specifically irrigated, where you can see kind of the spaces in between all the different irrigated fields are definitely drying down. Additionally, the top half of that lower circle we're calling B was irrigated as well, and you can see the comparison between particularly the upper left-hand corner of that between the 2 different days, changing soil moisture content significantly, along with the top quarter of C that we're pointing out there. So we're continuing to test the system over all sorts of different crops, soil types, and putting together a catalog of that, so that we can start services. We're hoping to be available as soon as the spring of 2021. We're going to be providing the data from this through web portal-based data delivery, make it available anywhere. It'll provide quick processing that you don't have to use your machine for, and also make sure and store and keep measurement history so you can show the soil moisture developments over time. We're also working on changing converting the system so that we can make standalone sensors. So we can do things like ground vehicle mounted testing. If you have any other additional questions, I'd refer you to either we've put together a joint venture between the two of us called the Soil Moisture Company, or there's the contact information for both of our companies listed below. Thank you for your time.